so we know to avoid you. All right. And we are live, I think. Thank you. Welcome to the Brighton Data Forum. We are a networking, socializing, and skill-sharing community of data professionals broadly defined. We work in all aspects of data and cover all topics. Anything from data engineering and database management to data ethics, data science, storytelling, AI in particular. It's a topic of interest lately. And we meet every other month. Our membership, our growing membership, I think we're at 1,200 now, counts people in the data professions from enthusiasts and students to interns and individual contributors, managers, all the way up to the executive suite. And yeah, so we especially welcome students and enthusiasts into the fold, and encourage you to reach out if you have something about data to say, something to share. Now, I'm sure you've all signed up at our meetup.com page, so that's sort of our home, our spiritual home at least. And but this forum also runs a Slack space that I welcome you, encourage you, cajole you, beg you to join and contribute to. This is where we keep the conversations going in between our bi-monthly meetings. And we organize social events, we organize, well, we do sometimes organize bike rides, going out for a pint, various things, just to have continue the conversation between all the members. So so to get in touch with the membership, please join here and follow our program. Now, I really want to give my thanks and our thanks to the forum's various benefactors. And first is Silicon Brighton. They are an event organizing umbrella. They organize all these events, and I think even more by now. Basically, if you are in Brighton and in the tech sector or tech adjacent, then they'll probably have an event for you. And if they don't have the event for the technology or methodology or the field of your interest, go talk to them. They'll help you set it up so you can gather your like-minded individuals into a group, because they are growing this list of groups they support. Brighton Data Forum is proud to be sponsored by them for now, what, almost 5 years. They themselves are supported by all these and more local companies. I'm happy to report my employer is there too. So these companies are the sponsors behind Silicon Brighton, but there's a lot more than the sponsorship. There are volunteers, there are meetup organizers, various supporters. If you have an interest in bringing the community together around any of the previous meetups or your own particular meetups, they welcome your contribution to the project. Their values are here. So a bunch of really good words, but these are really good people. And for the Brighton Data Forum in particular, we are grateful for all their support. They help us promote the events. They help us get in touch with really good and talented speakers. They bring the audiovisual visuals along, and they help us with all the logistics. So again, my best thanks to the Silicon Brighton community for supporting this forum, which would have long since expired without their continuous infusions. Now, second and is the venue that we are enjoying. We really enjoy having our events here. We have, you know, this is central. People love coming here, and it's just you come right off the street into a warm space with to talk data. And this venue, which you probably know, it is Barclays Eagle Labs. And here to tell you about what Barclays Eagle Labs is Rowan. Thank you.
Hello, thank you, Oscar. So yeah, welcome to the Eagle Lab. This is the Eagle Lab in Brighton, and so we are a co-working space, but we're also a national network of business incubators. So what differentiates us from a normal co-working space is that we've got a thing called the business proposition, and it's support for your business. So to help you grow, scale. So whether you've got an idea for a business, or even if you're exiting your business, we can help you through that whole journey. And that might be kind of setting up a digital platform, growing your business, your existing business, or giving you access to some funding opportunities, mentoring, accelerator programs, lots and lots and lots of different things to really kind of help your business. So you'll see some banners around the room. There's a QR code, and it kind of details all some of the things that we can help you with. So if you've got any questions or anything like that, do kind of ask me, or give the QR code a scan, and you can kind of access a lot of that information there. And yeah, so we also love holding events in collaboration with different kind of networks. So if you have got an idea for an event and you want to kind of talk to me about that, also I'm open to suggestions, and we don't charge. We just kind of love to have things that are kind of in sync with what we do here. So yeah, perfect. A little tiny bit of housekeeping. Toilets just down the stairs, just over there. And then if there is a fire alarm, which hopefully won't be, just outside out by the Joker. But other than that, hand you back over to Oscar. And yeah, so if you've got any questions, do come and see me to ask. Thank you very much.
Yeah. Thank you, Rowan. Every time we get together here, there's always so much talent and so much knowledge and so much energy and excitement. I wonder, you know, if there's a way to funnel that into some kind of a new startup, new idea, new company. Well, that's what Eagle Labs, Barclays Eagle Labs is here to help you with. Did everybody enjoy a piece of pizza, drink of beer or something? Well, I really want to give my thanks to Richmond Mead Consulting. They have been sponsoring the forum now for 2 years, and absolutely lovely and consistent. They are knowledge center of everything Oracle. They're a big data and data science and analytics consulting company with worldwide customers, and lots of amazing projects. They also have a blog that is a source of, you know, the local source of fantastic content that I recommend keeping an eye on. So they've sponsored the forum for the pizzas and stuff, and they've also generously lent us their space, their office space for training events. And we'll be talking more about those training events soon. And so we'll be using their hospitality once more. But anyway, thanks Richmond Mead for sponsoring the forum. Now, we're almost at the main event. We're almost having our first talk started. But I wanted to interject here and put in some of my hobby horse slides, because we're almost at the time where the call for talks at the biggest data-related conference that Brighton has seen, which is here in which is scheduled in September. The Earl Conference, Enterprise Application of the R Language Conference, is coming to Brighton in September. This is a great scoop for the town, and they have you can get all the details about the conference on that QR code. But one thing I want to emphasize is that on midnight Easter Sunday is when the deadline runs out to send in a talk application. And let me just tell you why you want to be in that schedule. Here is the schedule, is the conference schedule. There'll be a day of workshops. This is an R and Python event. Has expanded to cover both. Yeah, it's going to happen at Grand Hotel. It'll be a day of workshop followed by keynote speakers and talks with upmarket catering, which I'm super curious about. And then another, 2 days of that with a dance on the i360. Now, if dancing is not what appeals to you, then maybe this will. Their keynote speakers are of the top quality. We have Andy Field from University of Sussex, statistician, psychologist, and author of several books. We have Crystal Swift, who is the senior principal data scientist at the BBC. And if you followed their BBC news site, especially around the pandemic, you know that they have some formidable data teams on board there. And then Hadley Wickham. If you're in the R world, he needs no introduction, but he is a rock star developer and data scientist, and the author of many influential packages such as the Tidyverse, the ggplot2, and more. So these are the speakers. Hadley is the only one I've seen speak. He is a lot of fun and extremely bright, and you always learn something from him, and I have no doubt the others are great. If you want to share a stage with such eminent people, then the closing date for application is soon. You're going to have to come up with your abstract quick. There are 2 types of slots, 10 minutes or 30 minutes. And you can cover data projects in R or Python or some application you've been working on. And they would love to see it. Now, they have more motivation, but I'm just going to fly through that if I can. Because if you're not interested in talking, but you don't want to miss this event, okay, you don't have to talk at it. Their early bird pricing is still applicable and available. So you can contact Abby Brooks at Data Cove. Data Cove are taking over this event and bringing it to Brighton. That's why we're getting it right in our backyard. And yeah, so my encouragement for all of you to think of a talk and send in abstract. And yeah, they are sponsored. Okay, so that was me taking advantage of my position and just to advocate for something. Now for the main event that you all came here for. First, we're going to invite to the stage Gianne Ojeda, who's going to talk about machine learning and mental health. So here you go, Gianne. Thank you very much for coming.
Thank you. Thanks for having me. So once again, my name's Gianne, and I did a little bit of background, or I have a background in psychology with business and management at Sussex University. But shortly after that, I decided to pursue a master's degree in human and social data science. And using my knowledge in psychology and some of the data science techniques that I've learned from my master's course, I decided to fuse the 2 fields together and do my master's project on how machine learning can be used to better detect adolescents who are at high risk of developing mental health disorders in the future. And why I decided to pursue this topic, it's because, like physical health, I believe mental health is as equally as important, but it is often an aspect of a person that goes misunderstood or even misdiagnosed and overlooked. So yeah, so for this topic, I'll be talking about briefly the theories behind mental health and common diagnostic tools, and the methodologies that I've used for this research that I've done, and the performance of my machine learning models that I've developed, and how the implications it might have facilities like the NHS in treating mental health disorders. So the first theory that was proposed was called the biomedical model, which assumes that our feelings of, or the way we feel pleasure is regulated by biological systems. So this can be down to our neurotransmitters and the traits that we inherit from parents, like aggressive traits. But this has been heavily criticized because of its reductionist and dehumanizing approach. So to counter this, the model called biopsychosocial model, which was proposed, and assumes a more holistic approach whereby the social factors, the psychological and the biological aspect of a person all interact together, which determines whether we go on to develop such disorders or not. But because of the limited scope of my research, I decided to focus on the social factors, specifically how family has a very impactful element on someone's mental health. And I encountered an interest study actually by Mood and colleagues in 2017. And here they actually investigated the importance of family on mental health by looking at the differences between immigrants and native-born participants. And here they looked at the status differences, the differences in family structure and the relationships, and the difference between how much they exhibited or displayed internalizing or externalizing problems. And interestingly, despite the fact that immigrants face more poverty, more discrimination, they found that the immigrants had better mental health state than the native-born counterparts. And most of that was actually attributed to their family structure. In the immigrants group, they actually found that the common family structure was the nuclear family, where two of the parents were present and were engaging in the child's personal and school life. So this begs the question, is family an important predictor of mental health in the future? And upon reading more on the literature review, there's two common methods of diagnosing someone. And one is the questionnaire-based screening tools, where participants are pretty much just asked to rate from 1 to 10, for example, how they feel or all of this and that. And then based on their scores, they're either classified among a certain group or not based on validated cutoff points. And this is quite a cost-efficient method because it doesn't require any specialists to implement it. However, there are issues with trying to adapt it to other cultures. So say if you want to ask the same question to a participant that comes from a different culture, they might interpret the questions a bit differently. So it might not be comparable. And the second one is the patient-physician interaction, so basically therapies. And this is seen as the most reliable method for diagnosing mental health, but there's issues with people, because I think there's stigma around mental health, so not many people want to seek help because they're afraid to be labeled. And also things with like other people can't afford such therapies. To counter this, I thought, why not use machine learning to overcome the disadvantages of the current diagnostic tools. And for anyone out there that's unfamiliar with the logic behind machine learning, it's a subcategory of artificial intelligence, and it works by imitating the process of human learning by analyzing big data. And there's two types of algorithms. One is the supervised machine learning algorithms, and these models use data that already have pre-established values, so you already know the variables that you're working with. And then the other one is the unsupervised machine learning models, where data that it analyzes, it doesn't have pre-established values, so you don't know what you're working with, but essentially it does try to find the hidden patterns and data clusterings within the data. And the whole point of the algorithm is to try and find the right balance between bias and variance. So as we can see in the animation here, you can see based on the scatter plot, it is quite a positively correlated graph. But if we just draw a single straight line to outline that relationship, it kind of simplifies the relationship. So in that scenario, it would be high in bias. Whereas the more complicated the line gets, the variance increases because it captures a more complex relationship between the data points. So back to my study, I had 3 objectives. The first one is to build 3 machine learning models to be able to classify participants who are at high risk versus low risk in developing mental health disorders 3 years later. So this is essentially a classification problem. And the second objective is to optimize these 3 machine learning models to improve its classification performance using a method called grid search CV, which I will go into in a few slides. And then the last one is to evaluate these machine learning models using common performance metrics like accuracy, precision, and recall. And regarding my methodology, I decided to use the dataset that was collected by the Millennium Cohort Study. And here they collected data from the age of 9 months through to the age of 17. And I think there's data that's released now from participants at the age of 22, but I'm not sure yet. But specific to this study, I decided to collect data on family at the age of 14 to predict the mental health of participants at the age of 17. But because I used data from 14 and 17-year-olds, they were in 2 different files. So I used Google Colab and Python to merge the 2 files together to form one single data frame. And I think there was around 40,000 that I had to analyze. And the Millennium Cohort Study, they collected various sorts of data ranging from emotional conduct problems, family relationships, and all of that, using a variety of methods like interviews, questionnaires, and health records as well. And looking into the predictive variables, so I've decided to choose the parental psychological distress, the educational attainment of parents, so the highest level of education they've obtained, their alcohol consumption, the relationships with their children, household income, and household size, which was measured by the number of siblings that the adolescent had. So all of these were collected using questionnaires and established, questionnaires. And then finally, with the target variable, I decided to operationalize mental health through using the strengths and difficulties questionnaire score that they obtained. And I decided to transform this into binary classes. So anyone scoring 17 or above would be considered as high risk of developing mental health disorders. And anyone scoring below that would be low risk in developing mental health disorders. And I use 3 machine learning models. For anyone that's not familiar as well with the logic behind this, I'll start off with the K nearest neighbors. So say we've collected the data, we transfer it into a multi-dimensional space, and let's say the green dots represent low risk and the red dots represent participants who are at high risk. And we want to be able to classify this black dot. So this algorithm works by using the nearest data points to be able to classify itself. So say we wanted to use 5 nearest data points. So out of the 5, 3 of them out of the 5 are classified as low risk. So essentially that data point would be classified as low risk. And then the second one is the support vector machine. So the way it works is it tries to find the optimum hyperplane. So the hyperplane are the straight lines, and it tries to maximize the distance of the 2 classes together. And there's 2 types of it. One, the support vector machine, one of them operates under the assumption that the relationship between the variables are linearly separable, so it can be separated clearly by a straight line. And then the other one is where it's non-linearly separable, meaning to say that the features tend to overlap each other. There's no clear relationship. And this could be due to context-dependent factors. So for example, let's say we have a child that has parents who were alcoholics and went on to develop mental health disorders in the future. But we could also have a child that didn't go on to develop mental health disorders, even if they had alcoholic parents. So meaning to say the relationship is quite context dependent. It's not rely solely on whether the parents were alcoholic or not. And then finally, the extreme gradient boosting, which is the most powerful algorithm compared to the 2. And it works, it's basically an ensemble of multiple weak models together to form a single prediction or classification. So as each new model is added, it tries to reduce the residual errors of the previous model. And yeah, so I did some exploratory data analysis on my features as well. And as we can see here, a lot of the features are positively skewed. So on the top left, we can see that a majority of the parents didn't really experience any extreme forms of psychological distress. I think the cutoff value was 8 or 13, I'm not sure. So anyone scoring above 13 would be experiencing extreme forms of stress. And same as well with alcohol consumption as well. I think the cutoff value was 8 on that, but you can see there's some outliers there as well. And then the relationship between the parents and the child's relationship was also measured through asking them to rate how close they were with their mother and father and how often they argued. And I also looked at the data distribution of the target variable. So as we can see here, a majority of the data set, a lot of them, or majority of it was low risk compared to high risk. And if we were to train our machine learning models on this unbalanced data set, it could pose issues in the future because our machine learning algorithms would favor the majority class. So it would be better at predicting people who are low risk than high risk. And this might present costs in the future. Like say, for example, a participant who was actually a low risk, but was predicted or classified as a high risk by the algorithm, then we essentially would have wasted our resources on this person when we could have used it to a participant that actually needed it, and vice versa as well. So to overcome this, I used a technique called synthetic minority sampling method, and which essentially kind of generates fake data using data interpolation and I think the logic behind k-nearest neighbors as well. So after this, I've obtained a balanced class of low risk and high risk participants. And to better, to try and increase the generalizability of my machine learning algorithms and to avoid overfitting as well, I decided to split my data into 3 subsets. I think I first split it into training and testing using a ratio of 80 to 20. And then I further split the training set into training and validation. So the training set was used to create a model and assess its baseline performance. And I optimized the model on the validation set. And then I finally tested the final performance of it using the testing set. And the optimization method that I used was, I can't remember. I think it was grid search CV. So what it essentially does is it finds the optimal combinations of hyperparameters of each model to get the highest performance. And as a result, before I did the optimization process, we can see here that the XGBoost was highest in performing or better at classifying participants who are high risk or low risk, followed by the support vector machine and the k-nearest neighbors. But after I did the grid search CV, the performance of the models generally did improve, but not much for the XGBoost. It has definitely significantly improved for the support vector machine and the k-nearest neighbors. And I was also curious as to which features were more important. And so I decided to use a method called permutation of feature importance. And it works by removing each variable one by one to see how much the accuracy drops by. And as we can see here, that the parental distress score was the most impactful variable in our XGBoost classifier. So this might have implications in the future of using family-centered approach for therapies and for combating mental health issues among adolescents. And it's important as well to try and address the limitations of my research. So while it does try to alleviate the lack of transparency within machine learning by combining psychological theories with machine learning, it does have issues with generalizability beyond the UK because the dataset I used come from a UK-based sample. And also the strengths and difficulties questionnaire, which measured the adolescents' mental health, was parent reported. So this might not be as valid because a lot of the time as a child, you tend to seek comfort from friends, anyone outside your family, not from parents. So the parent scores might actually be an underestimation of the scores of the child's mental health. And another big thing as well, I've looked at the ethnic composition of my data, and as you can see here, a majority of the participants are white. So again, if we were to train our models on biased or unbalanced samples, then it could have implications regarding misdiagnosis of mental health among ethnic minorities, because it doesn't really account for the unique experiences that they experience on a daily basis. So yeah, to sum up, I've discussed the theories of mental health and common diagnostic tools, and I've potentially highlighted the importance of family and how it can be a significant predictor of mental health, and also how machine learning can be used alongside psychological theories to address mental health issues in the UK. And this just outlines the steps that I took to build my machine learning models. Thank you.
Thank you for that, Gianne. Well, I'll invite the audience to ask a question about what you just heard. So anybody want to? Yes, go for it, Peter.
Firstly, I thought it was great. Just reminds you of like how rigorous the academic world can be. It's really cool. I have a bit of a narrow question. It's about the use of, you use smoke to create the synthetic data for your training set, so the classes are balanced. And I often have like kind of mixed feelings about using synthetic data. I think it can be really good because sometimes the extra quantity you get like improves the performance. But did you also try just taking a subset of the overrepresented class so you get balance just by using a smaller group within the, I can't remember which was bigger. You had like the at-risk and the non-at-risk group. One was bigger, one was smaller, right? Did you compare the use of smoke against just taking a smaller group of the overrepresented class and see how the model performed with that?
That's a good question. I actually didn't, because I don't have much background in data science, what data science techniques that I could use, because most of the techniques that I've used from this project was based on the modules that the modules I was in at Sussex University. But yeah, that could be a good recommendation in the future.
I think maybe it would be. I think probably what you did probably was the right thing, but it's like it's often a good test to do, because like I think sometimes with this synthetic data, like sometimes you capture the relationship between variables, and sometimes you don't. And so I know it can just be a fun thing to try.
Yeah, I'll keep that in mind in the future. Thank you.
Thank you for that. More questions? Go for it, Peter.
So the data is all synthetic data, yes?
Yeah, on the high risk group, yes.
Ah, because then you would have no availability of the success rate of it.
It's because I think I use population level data. I didn't use like official electronic health records, which might have been the issue, because obviously with investigating
data privacy,
that, and also with trying to investigate mental health among like population level data, you're obviously going to get extreme scores regarding someone's mental health. Like it's not going to be the data distribution is not going to be centralized. So yeah, that was why that's one of the issues with using population level data.
Thank you.
Yeah,
one more here.
How did you choose the indicators? And was there any indicator that did not work out? Like you said around 6 indicators, but was there like, how did you choose those 6 and nothing else? And was there any other indicators that you looked at? Like one thing that comes into mind is if you can just use the ethnicity also as an indicator, that might also give some interesting results. So
yeah, I actually wrote a paper as part of my module about using ethnicity as a predictor of someone's mental health, and I think it might actually lead to some form of bias. But the reason why I chose the six input variables in total is because I wanted to try and get the full aspect of a family, like different aspects of how a family can influence someone's mental health. And the issue that I had was trying to measure the parent-child relationship, because the only way I measured that was, well, the only thing that the data collected from that was by asking the participants one question: how close were you to your dad, to your mum, and ask them to rate it from 1 to 10. So I think that itself was not really like a validated method of assessing closeness with the relationship with the parents. But the strengths and difficulties questionnaire, which assesses the child's mental health, was officially validated against a UK sample group. So yeah, but I think it's just the variable of measuring the parent-child relationship. That was one of the issues that I had.
Yes, so 1 second.
Thank you very much. That was a fantastic presentation. I'd love to actually read the report at some point. So really a lot in there. And sort of the key part of what you're discussing there is the comparison between those three algorithms. And from the data you've sort of shown there, it looks like the XG boost seemed to be the most performative. But I'd be really love to know, from a practical point of view, is there anything about that particular algorithm in terms of how difficult it was to implement and process the data that might sort of balance out against the fact that it was more performative?
I'm not sure, because the algorithm, the XG boost, I've decided to include it, but it wasn't part of the modules that I was taught. So the most difficult part for me was trying to understand how it works, because it was the most complicated algorithm, like multiple models merged into one single one. But yeah,
well, that might answer my question then, basically. So it's a very complicated model compared to the other two. So that might be, just from a real world point of view, the fact that it's more performative, the other ones might be easier to implement. Yeah, was what I was just questioning. But thank you very much. Thank you.
Thank you.
Anybody else? Yes, 1 second.
Hi, thanks for the talk. It's really interesting. Yeah, I'm really interested in like the practical applications of this, because I think it's really potentially quite useful in terms of efficiency for things like social support and obviously you mentioned the NHS. Do you have any kind of any thoughts on kind of the other potential applications of having something like this for non-for-profits or for like public organizations?
Yeah, definitely, because the whole point of this was to try and propose a framework for creating an automated system rather than have a specialist potentially diagnose someone, which can be really costly, and especially with the waiting time within the NHS. By using an automated system, the waiting hours would be reduced dramatically. So I think it has a lot of potential.
Thank you. Anybody else with another question? I'll ask a question of my own, actually. You mentioned your questionnaire data sets, which you presumably got through your student access at Sussex. Is this something that is available for others to work with?
It's an open source data set, so you can. I think the only thing that I had to do to get access to it was there was a website for it that I accessed, and they just asked me like, what's the project about, and then less than 24 hours I got access to it. But yeah, it's open to anyone.
Did I hear you correctly that you had 40,000 individuals or 20,000 individuals?
There was like 40,000 rows of 40,000 people, basically, like 40,108 if I was to be precise.
My next question is to the audience. Is anybody else excited about that? Okay, well, I'll take your deafening silence as a yes. In that case, please give a warm hand to Gianne.
Thank you.
Thank you so much. Thank you so much for coming to present. Yes. Now, we're going to take just 5-minute break, just a little bit of 5-minute break. So go up and get yourself a drink, get yourself a little bit of networking. We'll have another talk for you in just 5 minutes. Thank you. Let's gather back in. Attendees. Sorry, I forgot you earlier. To you on the internet, to you on the YouTube stream, if you have a question, type it in the comments, and Charlie will forward them to me, and we'll take your questions first after this talk. Okay? Sorry to forget you earlier. Anyway, so everybody ready for a more data talk? That sounded right. That sounded right. Okay, next up, Matthew Franklin from Brandwatch, machine learning engineer, to talk about custom sentiment. Thank you very much. Take it away, Matthew.
Hello, everyone. My name's Matthew, and I'm from Brandwatch. And I'm going to talk to you today about sentiment and how you can customize it. Yeah, it's going to work. Great. So this is going to be about sentiment. We're going to talk about that a lot. So I should introduce it briefly. Okay, so sentiment you can think of as a crude emotion. And you sort of think of emotion as being a fact, like someone's happy or they're sad. But when you're dealing with documents like text, sentiment can be an opinion. It depends on who you are and what you think about the world. And this is what the customization is about. When you're customizing sentiment, you're not customizing it to alter facts about the world. You're changing the classifier to match you and your opinions. Okay? So I'm going to be talking about Brandwatch and sentiment and documents and everything like that. I should probably introduce all of that stuff first. And then you can understand what I'm going to talk about when I talk about how we implement the custom sentiment classifier. Okay, so we'll start with what is Brandwatch. And Brandwatch was founded in Brighton, and we monitor social media for brands, for like large clients. They're interested in what people are talking about. And so we go off to Facebook and Instagram and all of that and collect public posts. And then we got things like the author and the time of day that it was posted and so on. And we aggregate all of that data for our clients. And what do they do with it? They look at things like this, which is big aggregations of that data, because there's so much. You know how big social media is. There's tons of stuff on there. You can't read it all, and you wouldn't want to anyway. So you get these nice aggregations, okay? And what sort of aggregations we get? We got like volume over time and sentiment and emotion and stuff like topic clustering, which is this word cloud down here, okay? And in order to provide the data that the client is interested in, they have to query the data, much like you would query a database with SQL. And they write a big query like this. And you probably can't see that very much easily, but you don't have to worry about it. It's like a lot of very specific terms that are picking out text which matches it, okay? And because people care a lot about this stuff, they write really huge queries, up to 400,000 characters long, okay? And we got to match that against all of the posts, all the public posts on social media. So it's pretty hard work. And what the kind of things they're interested in? They're interested in their brand, you know, who they are, how people view them, how people view their products, their competitors, and also for doing customer support. And that's really useful. So we do have a lot of data. Brandwatch has been going for years. We've had access to things like the Twitter fire hose, which is every public tweet for more than a decade, I think. And so we got trillions of posts, yeah, petabytes of data. It's way too much. You've got to aggregate it. And sentiment is a really good aggregation. Okay, so what do our clients want from Brandwatch? Yeah, why would they pay to use us? Well, I've mentioned it already, but we've got customer support. When you're bad-mouthing a product or a brand on social media, they want to hear about it so they can reach out and try and address your problem, and then maybe you'll shut up. You know, or say nice things about them. How about that? That would be good. You can also, this is why I got my prop. Okay, here is Diet Coke. Now, you can also find out about your own products and how people perceive them. So back in the 80s, Diet Coke was advertised with like swooning women looking at muscly men. Yeah, things were different back then. And it was advertised to women to, you know, because they care about their shape. But like men care about their shape too. Let's not be sexist or anything. So Coca-Cola Zero came out, and it's basically the same, but it's slightly different taste, a little bit. And it had this really masculine can, very black. And they listened to how people were talking about it on social media, and they discovered that they had like this very masculine thing that women didn't want to drink. And so they adjusted the look of the can so that it was more inclusive, because everybody cares about their weight, you know, especially me. So this is like an example of using social media in order to identify how people feel about the product and try and improve that. And then you get like spying on your competitors. How about that? Yeah, you can do all this brand analysis, and you can check out your competitors, and you can find their weaknesses instead of their strengths. Like, what opportunities are they leaving? Yeah, it's pretty fun being a spy. I wouldn't mind that kit. Anyway, that's what BrandWatch does. So now we have to have like a demo so that you can actually see it. Yeah, but demos are poison for presentations. They're so bad. This is Steve Jobs, you know, head of Apple, going on to the internet, or failing to, with his fancy new iPhone. Yeah, do you remember when Elon Musk got someone to smash up the Cybertruck on stage? That was awful. I'm not going to do that, but I'm going to pretend. So I got slides, see? And we're going to pretend that we're going through the BrandWatch consumer research product, okay? So I just logged in, and it's like, welcome to consumer research, Matthew. And I'm like, oh, it knows my name. And I'm going to be looking for conversations about the Wendy's fast food chain, okay? So I'm here, and I'm like, well, what do I do? Look, get quick insights on a brand, person, or topic. Even better, it says AI-powered. It's going to be amazing. Yeah. So I type in Wendy, and I get Wendy's, American International Fast Food Chain Restaurant. That's looking pretty good. And then I find this, okay? So we got squiggly, and that's like volume over time. It says it right there. And it's looking pretty flat, and then suddenly it spikes up. What's here? Something happened. And so I want to make a query out of this and dig into it a bit more. Okay, so I press that button that I've circled. And then, like, I'm impatient. It's collecting the data. It doesn't take very long, but this is why this one's a little bit flatter. Well, we can still see there's a big old spike. I can probably work with this. And now I can change all of the graphs and have a look into it in a little bit more detail. So what do I want to find out about this spike? Well, I want to find out how people are feeling, right? So I'm going to break it down by sentiment. And I do that, and I see this. And so we've got like a low constant amount of positive sentiment in green, a sort of highly varied neutral sentiment, but an increasing amount of red sentiment. Yeah, bad stuff. Don't like that. So what's going on here? And here I use Iris, okay? It's a peak detector and explainer, and it's pretty neat. So I click on that button, and it's like Iris detected 2 peaks. There's this peak in the neutral that I don't really care about that much, you know, whatever. But there's also this peak in the negative sentiment, and most of it, almost 3,000 retweets of this tweet. So what is this tweet? Okay, I'm going to read this out because it's got some acronyms and stuff. Remember when the Black Lives Matter activists burned down a Wendy's in Atlanta? They were finally convicted. For their crimes, they will pay a $500 fine and receive no jail time. Remember, the peaceful insurrectionists that stormed Capitol Hill will be in prison for years. Okay, I had to, you know, expand the acronyms, but here we are. You got the gist. So these are negative sentiment tweets. Not negative about Wendy's. Wendy's is like a bit player in this, someone who's standing looking, oh, there's a crime. What? Yeah, what? Okay. So this is a problem, isn't it? Because that was a Wendy's query. I want to find out people talking smack about Wendy's. So the last thing is, you know, we all love ChatGPT. I just thought I'd stick this in here so you can see that BrandWatch is hip and cool. And we got like automatic summarization using ChatGPT. So here we go. Outrage over the punishment, blah, blah, blah. And also negative restaurant reviews. That's probably what I was interested in. But yeah, it works. And it's pretty good. So yeah, that's Brandwatch. And now we can talk about sentiment, as I've given you like a brief introduction to how you'd use it. But we should dig into what it actually is. So what is sentiment? So sentiment, here you go, dictionary, always useful, yeah? It's emotion or feeling or a thought or a view or an attitude. I'm not going to read all that stuff out. So we got like crude emotion. I like that definition of it. And it sort of splits it, positive, negative, neutral. So we got like Friday is the best day, positive. Life is so unfair, negative. The earth is flat, that's a statement of fact. And it's neutral, even if it's wrong, okay? So it's not making like an emotive argument there. Now, what does it look like? You've already seen like me breaking down the Wendy's thing, and now we've got Burger King. Okay, you can see a theme developing here as well. And we got volume over time, so it's all over the place. And then we look at it broken down by sentiment, and we're like, there's a few people who are consistently saying nice things about Burger King, but oh my God, their negative sentiment is wild. And that's why I like using Burger King as an example, because they're like a bit edgy on social media and it often blows up. So why do clients care? It's because this is what a crisis looks like and they want to address that. Yeah, this is why we have sentiment. This is why it's such a bedrock capability of our platform. And you can see here there's like a bunch of stuff going on. But more than that, and sentiment, because of this, is used by every single client. We can think of like their customer support, people measuring how well their brand is doing in their products, and people spying on each other. Yeah, it's really good. And we can think of it again, like that iris thing, that was really good when I used it on the negative sentiment peak. Yeah, and so sentiment becomes like this baseline capability of your platform that you can build so much on. And that's why it's so important that it's accurate. You know, you want to build on a solid foundation. So we know what Brandwatch is. We know what sentiment is. And now we get into the meaty part. Why do we need to customize it? So what client does need custom sentiment? Okay, I'm going to tell you that we use a large language model in order to classify sentiment. And this is because when people go on Twitter, they write like, Wendy's sucks, yeah, or something like that. And how are you supposed to figure out what that means? You need context. Where does the context come from? If you write a rules-based system in order to do sentiment classification, you have to bake it in all those rules. And that's a nightmare. So you have a large language model that's been trained on like the internet, the cesspit that is the internet, and it picks up a lot of knowledge about the world. And you're relying on that knowledge to tell it what the words actually mean, what their context is. Now, there's a problem with this in that, you know, it's the internet. And the context, the culture that develops on the internet may not be desirable. And so we have to think about like what we're choosing to use as the baseline for our sentiment, what context we're using. And so we can imagine this. We can go through like one utterance, which is this woman talking to a large language model saying, imagine an executive committee member. And the large language model responds, a board member. Let's name him John. Now, she's clutching her head, so this conversation is not going well. Why is it not going well? What's so bad about John? Well, why is John biased? We can think about it in a few different ways. John is an English name. There are variants of it in other languages, but they're not spelt J-O-H-N. It's a male name. There are like female variants of it, but they're not spelt J-O-H-N. English countries are majority white. And what's more interesting to me, at least, my brother's name is John, is that it's a name of someone who's a bit older. Like John, 2010, that was the last time it was in the top 100 baby names. So it's not popular anymore. So that large language model imagined a middle-aged white man as that executive committee member. And when I say that, then you see that it's bias. Now, the problem here is that the language model is going to be full of bias. Like, it's the beliefs around the world that it's picked up. And which ones do you want to keep and which ones do you want to get rid of? Yeah, and why do customers care? What does it matter if the executive board member is named John if you're making a sentiment classifier? Exactly, yeah, much better. Yeah, so customers care because they're doing things like measuring sentiment and because brand names can have sentiment associated with them. So if I was to say to you, like an Apple phone, you've got a certain image in your mind. Now, how about Windows Phone? Yeah, GTA 5 came out a while ago, and there were 3 protagonists in there. And the rich white man had an Apple phone, and the psychopath hillbilly redneck had a Windows Phone. Yeah, sentiment is inherent in like brand names. And we can see this here. I ate at Burger King, which is a statement of fact. It's not emotive. Yeah, negative sentiment. And it's not like a little bit, it's really bad. Okay, and then we got KFC. Now it's neutral. Apparently, the language model prefers chicken. And then we have We Love Falafel, which if you haven't been to it, it's like in the lanes, very nice. Now, obviously, this is positive for good reason. And if we think about just the name of it, We Love Falafel, that is a sentiment-bearing phrase. And so if we make all of these brand names neutral, then we can actually end up harming our sentiment classifier because suddenly now love doesn't mean positive feeling. Okay? So we got a problem here. We want to choose what we care about. Now we could try going even further and creating a blank slate, a tabula rasa, their mind before it receives the impressions gained from experience. And we could remove all of this bias from the model. Okay? Imagine that, going back to rules-based systems. And I've said it many times, but we stereotype in order to make decisions fast and to operate quickly. And the large language model stereotypes in order to be able to do its job more effectively. And on average, it helps. Yeah, maybe people really do hate Burger King. And so a sentiment classifier about conversations about Burger King should be negative. Okay, now, if you want to read about clearing out these kind of associations that you dislike, you can read this blog post, Machine Unlearning for Harry Potter. I thought it was very interesting. Someone trained a language model to forget about associations between like Harry and Hermione and Ron and Wizarding and all of that. And it mentions explicitly that the performance on some open-ended tasks was harmed as a result of doing this. So we need some bias, but we need to choose it. Yeah? Tweets need bias because people talk in partial thoughts. Okay, all right. We finally made it to the implementation. Well done, everyone. So we need to change the classifier for every client, but how are we going to do that? Well, we're going to customize the sentiment model, aren't we? And in order to do this, we need data, we need tools, and then we need a model that the tools can run, and then we need to train the model. Okay, so I'm going to go through each part of this. Data collection, all right? So we're training this based on our clients being unhappy with our current sentiment model. So they log into Brandwatch and they see stuff like this. Burger King mentions found in a positive context. That's what the title says it's in. And I've typed in a search of inedible. And I found these. Yeah, absolutely vile. The king was so burnt. The only thing from BK I can stomach. They don't sound very positive to me. Okay. And then we've got that Wendy's tweet earlier that's neutral about Wendy's, but is very negative. Yeah. So a client's going to pick a small number of these and then complain at length to our customer support about how terrible our system is. Okay. But, you know, it's a complex problem. And so they've got these, but that's not enough to train a classifier on. If you've got like 10 documents and you train a classifier, it's not going to work out. So we need more. We need more, and we need, and the clients are essentially expressing their opinions by selecting these specific documents. So we need more examples, and this is where OpenAI and ChatGPT makes a second appearance. What we can do is we can use ChatGPT in order to classify more documents in a way that's consistent with the opinions that the client has expressed. Okay, how do you do that? We come up with a big old prompt, all right? You've used ChatGPT probably, and you've used it to do your homework, and you're like, you're an expert in my subject at school, and I want an article about like the Roman Empire. And this is like a good prompt framework if you're going to do that sort of thing, okay? And the thing here is that you're going to have like you provide this big prompt and your examples, and then ChatGPT comes along and says, well, that first one, yeah, I feel like that's a bit negative, and so on and so on. And if you're on an enterprise client, you're paying for every word it utters, okay? And then you have to get another person to look at all of the guff that it's come out with and say, does it say positive or negative or neutral? So that's no good. It's too expensive. What instead you can do is use the API in continuation mode. And this is actually the language modeling that language models are named after. Predict the next word. And here we've got like an example prompt of translate English to French. And it gives a few examples. And then it's got the word that we actually care about, cheese, okay? And then the next word, which is what ChatGPT is going to predict, is going to be the translation of cheese, okay? And you can read about this in Language Models, A Few Short Learners. It's quite a good paper. And with this framework, we can come up with a way to classify our documents by having ChatGPT come out with a single token. So here is an example. I definitely made this up, okay? You are an expert in determining the sentiment that the text expresses towards a Wendy's fast food brand. That's our task. Then we come up with some examples. First one is, my life sucks. At least I have Wendy's burgers though. Sentiment, positive, yeah? Text, found a rat in my burger. I named him Phil. He lives with me now. Sentiment, negative. Okay, and then text, those protesters at Wendy's spat at me. Sentiment, neutral. Okay, now we want to classify our document, okay? Text, rats found in Wendy's burgers are unusually intelligent, able to solve the New York Times crossword. And then we give it like the start of its answer, sentiment, and then it comes up with negative because rats, you don't want them in your burgers. Okay, now it should produce just this, and then we'll have our classifications and it'll all be great. But if you've used ChatGPT at all, you know that it loves to waffle on. And so this time it says, this text expresses negative sentiment about Wendy's. Rats at a fast food restaurant are a public health concern. I mean, it's right, but it's not helpful, yeah, because we need to get someone to read this and to work out that it said negative. And I'm going to say to you that if you're doing this sort of thing using the API, the temperature parameter is what you need to use. You need to turn that down to 0, because that is used in order to make it produce more realistic output. And what it does is it makes it randomly select words a little bit, yeah? And if you're trying to use this as a classifier, you don't want it to randomly select the wrong class, okay? So put the temperature down to 0, and then hope that it only misclassifies a small number of documents. So we do all this, and we try and get a balanced data set, okay? 100 documents of each class, and it might take a while, and we might have to do quite a few documents. But you've got to realize that you need every single class, because if you train a classifier and you have no neutral documents, it will never predict neutral, or positive or negative or whatever. Yeah, and you talked about this in your talk. So collecting data costs money, and this is what we're trying to minimize, yeah? If you think about it, if clients have to come up with 100 of each mentioned, then only a few clients are going to use this, and so fewer people are going to pay for this, and that's like losing money by having not that many people use it. If we pay people to collect the data, that costs money. Using ChatGPT, it's hopefully cheaper, but it still costs money. So you have to optimize it by making a shorter prompt and by reducing the number of tokens it produces. Okay, so that's data. And now we're talking about tools. And I'm just going to quickly go over these. It's like what we use at Brandwatch. And if you want to do this sort of thing yourself, then that might be of interest to you. So we use PyTorch. And I got 2 out-of-date graphs here to show you how awesome PyTorch is. The top one is the ratio of GitHub of academic papers using PyTorch versus TensorFlow. And you can see that in 2021, 3/4 of all papers for deep learning were using PyTorch instead of TensorFlow. And then we got like the GitHub repository split. And you can see that by January 2023, PyTorch is absolutely dominating it. So you're going to find more up-to-date research by using PyTorch, and you're going to get more help because more people are writing stuff in PyTorch. And we use Hugging Face. Yeah, everybody loves Hugging Face. It really is the best for doing natural language processing. And you should definitely check it out. And they've got tons of stuff on there, okay? And it makes it really easy to use models. So here we've got 3 lines of code that is a sentiment analysis system, okay? Great. Job's done. Why did I spend so long on this talk? Anyway, yeah, there's loads of models. You can try them all out, and they're really good. And we're using a transformer model. Okay, and now I don't know if you're familiar with it, but there's the paper. Attention is all you need. Okay, and transformers really are the best for natural language processing. They have been the best for ages, ever since BERT came out in 2018, and ChatGPT itself is a transformer model. Okay. Elmo was actually a different language model. You know, you say this. All of these crazy names have been net used, okay? So, and, you know, I will add that Hugging Face makes it really easy to train models. This is actually like longer than the slide, but that's because there's so many options. But it's in about 5 lines of code in total to train a model. And they've got like a blog post where they go over doing sentiment analysis. So that'll be a good help. And finally, I made an example data set for you. If you like Wendy's and Burger King, then have I got the data set for you? Yeah, all of the mentions, all of the documents that were used in my little graphs are in this data set available at that URL. Okay, and I came up with a little notebook that shows you how to train a sentiment classifier from scratch. So you can have a crack at it too. And I've even included the original baseline sentiment from the Brandwatch system. So you can try and train one that replicates that, or you can come up with your own one that's even better. So how about that? So if you're going to do that, what sort of model are you going to use? Yeah. So you might use a small model like DistillBERT. That works really fast and it's pretty good, but you need a lot of data to train it because it lacks a lot of knowledge about the world. But if you've only got a few documents to train it, you're relying more on its knowledge about the world, so you need a larger model. If you're going to use like one of the current gen models that are like 7 billion or more parameters, then you're going to need a beast of a CPU, a GPU to run that. Yeah. So I wouldn't use one of them. Instead, what you can use is like one of the last gen, as it were, models that are about 500 million parameters, because they'll fit probably on your fancy gaming GPU. And so if you look at BART large, for example, that's 400 million parameters, and it should take up about 1.6 gigabytes, or 3 times that when you train it. So it'll probably fit on your graphics card. Okay, and it's available on Hugging Face. How about that? Okay, so if I just went through all of that, and I just introduced the model, then what kind of model are we using for the sentiment classifier? Well, we got a custom model because it turns out it's just code. Code and a bunch of numbers, and you can come up with code. It's fine. And so I really got to stress this. We've got very little data. Even with the OpenAI synthetic data, we've got very little data. And so we have to rely a lot on knowledge that the language model has picked up about the world. And they do incorporate knowledge about the world as part of their training. But language modeling, which is the process of predicting the next word in a sequence, only causes it to incorporate a certain amount of knowledge. Yeah, it can be a lot. But is there another task that we could do that would make it incorporate more? Yeah? Turns out there is. It's called multi-genre natural language inference, which is to take a document and a hypothesis and say if the document supports the hypothesis. So I've got an example here. A senior is waiting at the window of a restaurant that serves sandwiches. And the hypothesis is a person is waiting for food, okay? It didn't say person, and it didn't say food. Yeah, but the model should be able to see that that is entailed by that document. And then we've got another statement, a person is waiting for the bus. The document doesn't comment about like waiting at a bus stop or anything like that. So you don't know if that's true or false. The document does not entail that. And this task causes the model to incorporate more knowledge about the world and about relationships between things in the world. So we can use this kind of model. And we do. And we actually use a stack of them, okay? We use the same one and we ask it several different questions. We're running it multiple times per document. And we take all of those outputs and stick them in our classifier. And then that is another model, which then produces our final classification. All right, easy. And how do we train it? Training's got to preserve knowledge. And I really got to stress this because we've got so little data, it'd be easy for us to come along and destroy all of this knowledge that is inherent in these models. Okay, so we've got to be super conservative about our training. And the way that we do that is we train it incrementally. So to begin with, we just train this classifier model at the end. Okay, and when that's doing as good as it can, when it doesn't improve anymore, then we can train just a little bit of this MNLI model. And then we train again and again, and then just a little bit more and a little bit more until maybe 1/4 of the MNLI model is trained for this task, and the classifier is completely trained. Okay, and this is called gradual unfreezing, and there's a paper associated with it if you're interested in that. It's a very good way to train these models. And now, after all of this, you get to hear the training results. How about that? So training the custom sentiment classifier improved accuracy by between 10 and 40%, which is a vast improvement. Yeah. And so the clients should be really happy, right? And so now we can talk about evaluating all of this stuff that we came up with. And the thing is that the clients had this problem, and we can't go to them and say it's 40% better, be happy now. They have to actually assess this and see if they are happy. After all, it is to fit their opinion. And if they come up with more things that is misclassified, then we can go through the same process and train it further. Okay? And so how do we do that? Well, obviously, they select the data to annotate. They train, and we train and run the custom model on their data. And then they view the results and see how they feel about it. How do they feel about it? Well, we find out in an interview. You know, it's a structured setup that we repeat with several different clients. It's got open-ended questions, and we try and find out the recurring themes that come up in these conversations with the clients. We also try and improve the questions so that the next round of doing this gets better. And then we get to the outcomes. You know, maybe the clients love it and they pay lots of money for it. And then we stick it in production and everything's great. Or there's some problems with it, but they're not insurmountable problems. We can deal with them. And so we can go and we might spend the time to fix those and then try again. Or it's terrible and everyone hates it. And we give up on it. And, you know, that is realistically what the outcomes are. And I know, having worked on it for a while now, that I'd prefer it if they liked it, but I don't get to choose. So yeah, that's the end of it.
Thank you. Thank you very much for that, Matthew. I'd like to start by asking the remote audience if they'd like to post a question to us. Very good. You people on the YouTube stream, you know what to do. Go ahead and start typing while I talk to the audience in the room. Hello. So, Paul, you want to be first?
Yeah, you told everyone my name. Yeah. Matthew, wasn't it?
Yeah.
it seems counterintuitive that most sentiment is neutral. It just seems wrong. You know, most people have something to say and they say it because they're angry or they're sad or whatever, you know, the extremes. I was just wondering, over time, has the proportion of neutral sentiment decreased, increased as the models have got better, has remained constant? And also, what would happen if you forced no neutral option? Would they be proportionally the same, positive and negative, you know, split evenly? Or it just seems counterintuitive, neutrally so high.
I think that's a really good question. And I would say that I haven't tracked it over time. It does, you know, maybe it's my perspective that things are getting more polarized, but I haven't got any evidence to prove or disprove that. What happens if we only have positive and negative? Then what happens if people make statements of fact? And there's plenty of data sets where there are only positive and negative classes, like a 2-class sentiment classifier, but then it like imbues every statement with emotional charge. And if you're looking for like people who are actually genuinely upset, that might not be that helpful.
So there's no scaling on the sentiment. It's either positive or it's negative. There's no extreme there. It's just a binary thing, if you like, or a tri-Boolean.
Yeah, so this kind of classifier is on or off. Yeah, it's one of these three rather than being a little bit positive or a little bit negative. If I went back to you know, we love falafel, that bit, you'd see, here we go, that the actual output from the model does have these gradients, yeah, like it is split between them. But if you're creating like a line chart with 3 lines on it, then you have to pick.
Next question. Here you go.
You've discussed how you'd potentially change the sentiment around a brand token. Have any of your clients come to you and said, our customers don't speak like that. They have their own vernacular. Is there an argument for using slightly different cultural LLMs for different audiences? Like, I mean, we discussed teenagers, right? Teenagers speak different from 50-year-olds, right? Is it worth having a model that models the brand based on the language they use?
I think that's a really good question. And it's a great example of like a different domain of language. And you can absolutely have a different domain that more closely resembles the audience for your brand. And then it can pick up on specific terms. Now, if I click all the way back to the beginning, aren't you lucky? Then you find ping or peak, which is like what them youth talk about, right? So good or bad, apparently. But this is the... I'm not going to pretend to be young. I don't know. Okay. So yeah, exactly. You could train a model in order to better model this language. And then hopefully it would gain a better understanding about that context instead of the general context.
What about having...
Hold on, Pete.
What about running the same questions that you've built for the current language model on different language models that take account of age?
Oh,
is that hard?
Well, how would you account for age? Because people often don't declare their age with every single post. And if someone posts on social media and then you lose track of them, and then they turn up again on another account, it might be the same person and they've aged in between. I don't know. It sounds tricky, and it would be quite interesting in order to stratify like that. But if we think about like millennials and Gen X and Z and all of this, those are like bands of people that are all aging together that might have like a common cultural reference point. And so it would be interesting to be able to split it based on that. But it's reliably assigning individual authors to those bands that I think is the tricky part.
Would the language model take a huge amount of extra code to flag what sort of language the document is using to stratify it?
Yeah, so that's an interesting approach, and it's a little bit like language classification, like which language is the text written in, which you can usually do by identifying specific like characters that are used or words or whatever. And in the same way, you might be able to do that in order to identify the age range of the speaker or the culture in which they're immersed. But it's almost certainly to be much less accurate.
And a lot more code, yes?
Well, yeah, because you'd be running like multiple different models, and then they'd be voting on what they think and stuff like that. That wouldn't be an insurmountable amount.
Okay, thank you.
Yeah.
As a John, still in denial about being middle-aged, but everything else is fairly accurate on that. We're seeing great strides, and the language models are growing sort of with accuracy, sort of exponentially. But how do you, sort of as a business, see the switch to video and TikTok and the rise of that? I know you've got hashtags, but eventually there will come a point where pretty much everything is going to be video rather than text. And how do you see the future for that?
So if you were to process like a full video stream, you'd probably want a different kind of model, just like you have different kinds of models for image. But if you think about an image, if you were to process a video frame by frame, that would be very expensive. Now you could take images that drastically differ from the previous one as a sort of scene change and then try and classify them. Or you could come up with like a different model architecture, which is actually able to handle the fact that you're dealing with video, and then would have like object persistence and stuff like that as like features within it. But just thinking about like the computation required, I think that it would be quite expensive. And so it's likely that you'd want to do hacks such as taking those scene changes and then classifying them, or taking frames at a regular interval, and then just, you know, in your marketing material, say that you do video.
Those caption subtitles?
Actually, so you just said there's captions and subtitles. Transcribing the audio of the video is really quite easy. There's very good models for that, and you can strip the audio out of the video stream reasonably well.
Just so you know, there's models on Hugging Face that can do scene transition detecting, so it's all great. It's done for you all already. There's nothing to do.
Yeah.
1 second.
Hi, thanks for the talk. It's really interesting. Yeah, I'm interested about what other approaches you tried to get to this one, because it sounds like this one had a decent accuracy. Did you, for example, did you try any kind of like pre-trained word embeddings or like syntactic dependency tree parsing or anything like that to like pre-process the data before you trained anything?
So that's a really good question. And it's always worth thinking about the cheaper models that you can use, like the ones that you've mentioned would be quite a lot cheaper. And the thing here is that we do provide those. We've actually got like a random forest classifier available, but you're basically going to all of this effort to have your custom classifier and then cheaping out on the model. And then that reflects itself in the accuracy of the new sentiment that you get. So they're available if you want them, if like you're extremely cost sensitive when it comes to running it, but the accuracy suffers.
I have, sorry, here. I have one comment and one question. I think comments under a video can act a really good proxy. You don't actually need to analyze the video. You can look at the comments and you can just kind of get the sentiment from that, much cheaper, much more commercially viable. My next question is particularly for tweets. Does it detect sarcasm? Like, because it does not have the context and it's just like few words. How well does the model do?
So I'm going to answer both of those questions, or the comment and the question. And on the sarcasm thing, I like that one of the managers at Brandwatch used to always answer, yeah, we'll get right on that. And the problem here is that like something said in jest, in sarcasm, can be mistaken for someone's honest opinion on the internet. And so it's very difficult to come up with a sarcasm detector. And you might be able to like have a language model that does that. And we sort of might have got that for free, but I wouldn't rely on it. And then you're talking about like classifying the video based on the comments that are associated with it, which is a very good idea most of the time, until like I can think of 2 examples. So Activision Blizzard done some horrible things, and then they release like a new video for their upcoming game, and then people brigade it, and they're like, oh, clicking on the down arrow and saying that you suck, yeah, pay your workers, stuff like that. And is that really a reflection of the video, or is it a reflection of the sentiment that people are honestly feeling about that company and their behavior? Another one was, there was this Facebook Australian telco, you know, and they'd post like the most whatever stuff all the time, like, oh, you can get a great deal in Sydney, it's really wonderful. And their comments, they'd get like 10,000 comments a post. All of them would be slagging them off about their terrible service and all of that, you know. So sometimes people will sort of pick up on you doing something and use that as a chance to rant against you.
Hi, Matthew. That was an amazing talk. I wonder if you get enough sleep.
I'm feeling pretty tired right now.
Yeah, I was just wondering whether there's verification taking place behind the concept of sentiment, i.e. using more standard market research tools such as focus groups and things like this. Because sentiment to me seems like, you know, a great idea and certainly has marketing value. But again, it's very movable and it's very social media based. And if you were a brand manager, maybe you'd want some verification that actually the mood of the social media audience actually can be backed up by verification in other ways.
I think that's an excellent comment. Yeah, so does sentiment drive sales? Like, will more people buy something if they're happy about the brand? And at one point, we did have a polling part of the company that would try and do this kind of outreach and poll people directly in order to find out what they felt about brands and like, were they likely to buy them or not and stuff like that. And so there is a place for such things in larger marketing, but Brandwatch is quite focused on monitoring social media and can be used in conjunction with other tools such as direct outreach. And you can also try and, you know, come up with correlations between current sentiment and sales. But that's not something that I work on right now because I don't have the sales data.
More questions? More questions for Matthew? Well, if not, then please give Matthew a warm hand again and thank you, gratitude for this talk. Thank you, Matthew. Thank you. And keep it going for Gianne as well, for her talk. Thank you for your presentations, for introducing the concepts of machine learning and applying it to mental health and adolescents, and for telling us about this awesome data set, which I'm hoping you'll post on our Slack space so we can all have a play with. And thank you, Matthew, for demystifying use of large language models at scale at Brandwatch for custom sentiment. Now, how are you feeling? Is anybody thirsty? We're going to head over to the Hare and Hounds just across this roundabout here, the Preston Circus roundabout, and gather there, sit down, and continue the conversation in a more informal way. But I'd ask you to, as you leave, to just stand up and file out and make for the pub, because we need to clear up this space, and Rohan needs to get back to his family. So thank you very much for coming. Thank you so much to the speakers. See you at the pub. Take care. Bye-bye.